Hey everyone, today we're going to learn about FTC Part 2, Fundamental Theorem of Calculus Part 2, and it's all about evaluating definite integrals from a to b of some function. Well, to start, you have to understand what an antiderivative is. For example, an antiderivative of f is a function big F where big F prime, or the derivative, is equal to f. It's basically just taking the derivative but backwards. Let's do an example. What would the antiderivative of 2x be? Well, you can probably easily identify that as just having x squared as an antiderivative because the derivative of x squared is 2x. The important thing to remember about antiderivatives is that they're always going to be the same for each given function. They're pretty unique up to a constant. And what that means is that x squared plus 1's derivative is also 2x, and same thing with x squared plus 3, blah, 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 so on and so forth. And so we end up that the antiderivative of 2x is x squared plus some constant c. And this will be true for all these antiderivatives. They're going to be unique. The x squared is unique. It is the unique antiderivative for 2x plus some constant. The constant can be anything. Now, how do we use the antiderivative to find the integral from a to b of f of x? Well, it's actually really simple. The integral from a to b of f of x dx is simply equal to the antiderivative evaluated from a to b. And what this notation means is you're taking the antiderivative at b and subtracting it from it, the antiderivative at a. That's how simple it is. All you have to do is find a antiderivative of little f, plug in b, and subtract it from plugging in a. That's how simple it is. Now you can say goodbye to the Riemann sum definition, because look at how much work that is compared to simply just writing down f of b minus f of a. If you're an AP student, this next part is very important to remember. You need to remember all of your common antiderivatives. You need to remember x to the n or some number n. You need to remember e to the x. You need to remember 1 over x and the basic trigonometric antiderivatives, because those will show up very constantly on the AP exam when you're trying to take the integral of some function. These are some of the most common antiderivatives that you will need to use on the AP exam, especially the inverse trig derivatives. These are quite tricky because if they give you an integral with one of these derivatives in it, it's very difficult to spot. So you need to memorize all of these inverse trig derivatives. And the way I have them right here actually is from my experience, these are in order of importance. These are in order of importance. Arctan definitely shows up the most often out of all of these derivatives. So if you need to memorize it and you can't memorize all of them, just remember, this is the order that I noticed show up most often on AP exams in any sort of examinations in Calculus 1 and Calculus 2. Arctan is most definitely the most important, so remember that. These are all the important antiderivatives, and don't forget your plus c, especially when we get into doing indefinite integrals. When it comes to definite integrals with FTC2, your plus c doesn't matter as much, but just remember, again, these are a lot of the common antiderivatives, and these trig ones are in order of importance. All right, so let's do some examples. Our first one here is we have the integral from 1 to 4 of 2x dx. This is actually the same example that we did in our Riemann sum video, and it was a whole page of work. So let's see how much faster it is with FTC2. Well, the first thing we notice is that the derivative of x squared is actually 2x. So we can see that our antiderivative will just be x squared. So we know, because of the fundamental theorem of calculus part 2, that the answer to this question will just be x squared evaluated from 1 to 4, or 4 squared subtracted by 1 squared. And this is just equal to 15. Would you look at that? We have our final answer in one line. That was so much easier than doing Riemann sums. Here's our second example. It's a little bit more difficult. We have the integral from 0 to pi over 4 of secant squared x. Well, right now, because I've memorized my trig derivatives, I can recognize that the derivative of tan x is actually secant squared x. And so we have our antiderivative right here. That's why it's so important to memorize your trig derivatives and memorize all of your derivatives, because you can easily spot it and not get caught up by these type of questions on the AP exam or whatever exam you're taking, and save so much time to focus on some of the harder computational problems. So we know that this is going to be tan x evaluated from 0 to pi over 4. Well, that's tan of pi over 4 subtracted by tan of 0. This is just 1 minus 0, and you end up with a final answer of 1. Look at how easy this is if you memorize your derivatives. All right, last one. Let's take a look here. This one's a little more difficult. It looks like we have a 4 in the numerator, and it's kind of difficult to spot what could be an antiderivative of this. So I say simplify it as much as possible. So I'm going to take the 4 out front and see if I recognize anything. What we end up getting is 1 over x squared plus 1 dx. All right, do we recognize anything from this? Well, if you memorize your inverse trig derivatives, yes, you do. We know that the derivative of arctan x is actually 1 over 1 plus x squared. And we have the same thing here, except the 1 and the x squared have switched order, but that doesn't matter because they're equal to each other. So we have our antiderivative. Again, that's just how important it is. I remember arctan shows up a lot. When I wrote the AP exam back in the day, arctan was actually one major question. And that's why I wrote it in order I did. Remember your inverse trig derivatives. It's very important. And now let's continue. Now that we have arctan as our antiderivative, we can write this as 4 times arctan of x evaluated from 0 to 1. Or 4 times arctan of 1 all subtracted by arctan of 0. All right, well, now let's evaluate. This will end up giving us 4 times arctan of 1 is pi over 4. And arctan of 0 is 0. And this just gives us pi. And look at that. That's our answer. This would have been basically impossible to answer in a timely manner if you hadn't memorized your arctan antiderivative, which is why, again, it's so important to memorize it in order. Arctan, the most important, I'm telling you. It's good to know. It'll save you so much time, and that way you can spend your time on problems that require a little bit more thinking than these elementary integrals. All right, that's all I have for you today. Thank you.